Ladies and gentlemen, please welcome General Manager, IBM Power Systems, Ross Mowry.
Welcome, everyone. Thank you very much for coming here today. We appreciate it. Smarter Systems for a Smarter Planet. This event is part of our worldwide rollout of the new POWER7 set of announcements, and we want to make sure that you get a perspective that this is an integration of innovations up the entire stack, not just the microprocessor, but up the entire stack, and what that can mean to your business today, your business in the future. We hope to give you a perspective on that, not just from a base point of view, IBM strategy point of view, from a hardware point of view, from a software point of view. We've got a set of speakers here today that will give you some unique perspective and hopefully some great information that you can take back with you. The agenda is up here now. The first speaker will be Rod Atkins, who's the Senior Vice President in charge of IBM Systems and Technology Group, and he's going to give you a real broad strategic view of what's going on in the industry and why smarter solutions are driving some interesting needs and need for innovation within the system stack from vendors like IBM and our partners. I'll come back up and give you an overview of the announcement and some perspective on that. We're going to have Christopher Hales come up and dive a little bit into virtualization and management, because that's one of the keys in this ever complex and changing world. The key to flexibility and ultimate usage of your systems is around virtualization. Robert LeBlanc, who's our Senior Vice President for IBM Middleware, will come up and talk about smarter software and how smarter software and smarter systems designed together will really be there to solve your business problems. And then finally, we're going to have a panel with a number of our partners and clients to give you their perspective on POWER7 systems. So we've got an action-packed agenda for you. Thank you again for coming, and now I'd like to invite up my boss, Rod Atkins, Senior Vice President, IBM Systems and Technology Group. Rod?
Okay, thanks, Ross. Thank you.
Thank you.
Okay, so first of all, good morning. And it's great being here in London because we do think we have a very exciting set of announcements that I'd like to take you through. But first, I want to establish a context for the team. Because we do think that these offerings will start to change the prevailing view that we see in the industry around performance. Now, Ross talked briefly about POWER7, but this is really the first in a series of announcements that we will be doing throughout 2010. And we do think that these are some compelling offerings for our clients, as well as a compelling statement for the industry. As I go through this, you'll see that these systems are really designed and workload optimized to address the needs of the infrastructure today in terms of lowering cost of computing. The second thing I would say about these systems, we do think that these systems are best prepared to deal with some of the demanding workloads of the future. And you'll see me build on that theme as I go through establishing a context, because we do believe that given some of the technology trends that we see in the marketplace, given some of the opportunities that we've seen working with a number of clients across many different industries, there is a huge opportunity around transformation. So why now in terms of a new type of system? Because that's what we're going to describe, really a smarter system that's designed for this smarter planet opportunity. And I wanted to first start off with this chart, because I think this chart makes a very interesting point, that if you look at computing really over time, you can almost argue since the inception of the transistor, we've seen, I would describe, steady or gradual growth over time until now. Because now that computing and intelligence is being embedded into different types of things, if you will, and these things are becoming much more intelligent, you're now beginning to see this huge explosion in terms of the types of transactions, new types of transactions that will be created, driving more and more data. And when you start to look at the fact that intelligence is being embedded across ecosystems, like healthcare. Intelligence is being embedded in the things like supply chains. If you look at the fact that there's over 4 billion mobile subscribers in the world, and then just last year, if you just look at things like RFID tags, that is one of the key components in the world becoming more intelligent. There was 1.3 billion RFID tags manufactured or produced in 2009. If you also start to consider that by 2011, it'll be 2 billion people on the web, and then when you look at this chart, it will be a trillion, what I would call Internet of Things. So things like cars, appliances, roadways, pipelines becoming much, much more intelligent. And a lot of the work that we've actually done with customers in a number of industries will suggest that the world infrastructure is truly changing because of this opportunity around instrumentation, this opportunity to interconnect things, and the fact that many of these devices are becoming much more intelligent. Hence our view around the Smarter Planet opportunity. Smarter Planet enabling more and more transactions, and as part of that transformation, we do see an opportunity to infuse a level of analytics, real-time analytics, and prediction as part of managing the opportunity moving forward. And I'll build on that theme as we go through. Now, all of these new transactions, this explosion of data is all occurring on top of an infrastructure today that's already under pressure. Let alone if you start to think about the needs required to deal with this explosion of transactions and data. You look at some of the challenges that some of you see across your business in terms of, and depending on, the environment, energy consumption and cooling of IT continues to be a large challenge when you look at this on a global scale. When you look at the challenges that we have from complexity, in terms of managing the infrastructure, driving more simplification and better capabilities around management and administration. We still continue to see challenges in that area. And then when you start to look forward in terms of this explosive environment, we expect to see 10x growth in data. And 80% of that growth is actually going to come from all of these new types of devices, and most of that data will be unstructured. Again, driving the need for better analytics capabilities. And then you can see some of the things that we're looking at in terms of the amount of information that will be exchanged across the internet every second. So a tremendous set of changes and dynamics that we will see across the infrastructure. I want to use one example to make this point, and you'll hear more about this area, but I wanted to talk just quickly about what's happening in the utilities area. And we actually have one of our partners here that we've been working close with, a company called eMeter that you saw on Ross's chart, where they build applications for smart meter environments. But to sort of make this point, we've been working with a number of utilities around the world as they move from these analog style meters to smart meters. And this is a good example. If you take one utility that's managing, say, 10 million smart meters, and if you read those meters once a day, you can actually once a month, you can see where it is 120 million transactions a year. Now, if you start to read those meters, which is the goal, a minimum of once a day, you can start to see this explosion in terms of the number of transactions per year, and in this case, 3.65 billion transactions a year, which equates to over a petabyte worth of data. So a large amount of data being generated. We also have a target where we want to read these meters every 15 minutes. And you can see what really happens here the moment that starts. You're now dealing with 1 billion transactions a day, or 350 billion transactions a year. So quite dramatic in terms of the amount of transactions and the amount of data that's being created. And this is just really one utility managing, looking at 10 million smart meters. You'll also hear on some of the work that we are doing to look at even 50 million meter benchmark, and it's going to require systems like POWER7 to deal with that, because as we go through this, you're going to need the systems that can provide the raw performance and horsepower to deal with this type of environment. But we're going to also need the systems and solutions that starts to infuse more intelligence into this process. So it's interesting to see all of these transactions and the generation of all of this data. But what if you can now start to look at the data and look at the transactions and extract insights from that data? What if you could start looking at the patterns and start to predict outcomes? So we, as part of designing POWER7, was to focus on this in two dimensions. One, you're going to see, as Ross described the system, some fantastic performance characteristics in terms of what we've done in partnership with our software group colleagues and some of our application or ISV partners. So you're going to see a level of performance and scale that's really unmatched to anyone else in the industry. But you're going to also see us, as we continue to roll out solutions around things like smart analytics, building capabilities that will allow true transformation. So if you go back to that utility and think about the fact that all of this information needs to be collected, processed, and analyzed, you now have the opportunity to look at providing new levels of value. So utilities can be in a position where, as they understand usage of, say things like electric and gas, they can start suggesting things in terms of usage patterns. Or understanding this information, they now have the flexibility where they can start to think about perhaps acquiring energy from different sources. So now that you have all of this and the infusion of intelligence, you now have a huge opportunity in terms of transformation. Now, how we're doing this and how we're approaching this, and you're going to see us build on this theme throughout the meeting, because this is frankly not an afterthought for IBM. This has been a well-integrated approach for a number of years, built on a pretty significant research and development model. Annually, in this space, when you look at it across the system stack, the IBM Corporation spends nearly $6 billion. POWER7 alone, as a family of offerings, since its inception, we spent well over $3 billion developing this integrated offering. And you're going to hear us talk about it at all levels. So this is not a chip discussion, and although it is a great microprocessor that you'll hear about shortly in POWER7, this is really a systems discussion. You're going to also, as this chart indicates, this is not a recent adjustment to our strategy or a reaction to things that's happening in the marketplace, or the fact that we're describing this based on a recent acquisition. This is something that we've been doing over years in terms of investments across the stack from a systems approach, so that we provide a well-integrated set of capabilities that's deeply optimized, that delivers this new level or this new definition of performance. And then the last point around intelligent performance, we do think through this optimization and integration, we will address many of the challenges that our customers see in terms of just having a better environment as it relates to better consolidation, better asset utilization through things like virtualization, and better dynamic capabilities built in the infrastructure through the automation features that we are rolling out as part of our total stack solution. So a well-integrated approach in terms of really leveraging innovation at all layers of the stack. Huge investments at the semiconductor level, huge investments in terms of the hardware integration level, huge investments in terms of how our middleware products have influenced the hardware design, and huge investments in terms of how we work with our application partners to make sure that we have a well-tuned system that will address your needs. So innovation and integration at every level. So with that, I wanted to really set a context first in terms of we do see some industry trends that I think our smarter systems are well prepared for. The first point is around, I think, this definition of performance will continue to evolve. So you have to have the raw performance, but at the same time, we have to continue to provide the tools and the capabilities to address more of the analytics and prediction type capabilities, which is really a point around intelligence. The second point, and it's really a key point, that these systems are cost optimized, and you're going to see some comparisons in terms of what we've done here to really address some of today's infrastructure opportunities, a new level of economic value that we packaged here. And then finally, we do think, when you just think about this opportunity moving forward, these are systems that we believe they're best prepared for dealing with some of the emerging and demanding workloads that we see in front of us. So with that, I wanted to set that context first, and then I would like to invite Ross Murray back up, where he will spend more time unveiling our POWER7 system. So thank you for your time.
Thanks, Rod. Thank you. So I'm really personally excited to be here today because I've worked towards this week of launching the POWER7 systems in their totality for over 2.5 years now that I've been working on this. So it's great to be here. I'm going to start at the bottom of that green stack that Rod just showed you, and we are going to build our way up to the top of that stack and talk about how innovation at all levels and integration is really the value for you. So at the bottommost level, the microprocessor, it is an innovative microprocessor in 45 nanometer technology. There is 8 cores per socket now, going up from 2 cores in POWER6 to 8 cores in POWER7. We're going up to 4 threads, so up to 4 levels of SMT per core on this chip. We've got some really interesting, a lot of interesting new innovative technologies in the chip. I'm not going to go through them all with you. Of course, you all know what integrated EDRAM at the L3 cache level is. So again, we won't go into that, but just here's something in a nutshell. We're going to do, with half the transistors of a comparable chip, have better performance and much better energy utilization. This is by far going to be the fastest, most efficient, and most reliable microprocessor ever built in the industry. And IBM and IBM's research and IBM's development labs are the only vendor ever to be able to do what we're doing with this chip, and that is to increase the number of cores on the micro, the number of threads per core, and the performance per core all at the same time. So this is a revolutionary breakthrough microprocessor that has self-built-in dynamic optimization of the energy it uses. And energy usage we know is a concern and an issue for many of you. And so from the bottom of the system up, the system has been optimized also to dynamically control and only use the energy needed to run the workload that is being run at that instant in time on this system. So it's a very efficient micro and system built on top of it. Just one historical perspective that I think is important, and I've talked to many of you one-on-one about this, and that is that IBM, more than a decade ago, made a commitment to this RISC system, this Unix system, this power system, this technology. And what we said is, we were going to invest for leadership performance, leadership price performance, and we're going to invest in a roadmap that you can count on so that you know we will deliver on the roadmap, your investments will be protected, and there will be sustainability and longevity to this platform. And so I'll just go back to the real revolution started with POWER4 in 2001, and we've delivered, as we said, with POWER5, with POWER6, and with POWER7. And as I was telling Rod, we didn't deliver exactly on what we said with POWER7. We are delivering it 2 months earlier than we had anticipated more than 5 years ago when we really launched into the design of these systems. So kidding aside though, we've got the reliable roadmap. I'm not going to talk about POWER7 or whatever we choose to call it in the future here today, but rest assured the teams in development have been working on that next generation microprocessor for over a year already. So again, unlike pretty much everybody else in the industry, we have a solid roadmap. We've delivered on it, and we intend to keep delivering on it. You can count on us. So we're introducing 4 new products today, 4 new hardware products, and I'm just going to briefly go through them and touch on them as we build our way up the stack. The first is the 750. So I know you all appreciate our sexy black boxes, so what we're introducing here today, you know, the Power Systems product line is a very broad line from blade servers and small rack-mounted servers up to very high-end, full cabinet-sized, high-end commercial 595 systems onto the largest supercomputers in the world. What we're introducing today are 4 systems that are right in the middle of the product line. Think of the high end of the entry space to the top end of the mid-range space. So we're introducing the middle of the product line with POWER7 technology. And yes, later on this year, we will introduce the bottom end of the product line and the top end of the product line. And if you want to talk about any of those offline, we'd be happy to do that. But right today, we're introducing the middle of the product line. So it's a 4-socket server, can have up to 8 cores per socket. You'll have your choice based on the way you want to configure it, of 6 or 8 cores per socket. It's a highly energy efficient system. Let me try to just put it into a little context here. So it is the fastest, highest performing 4-socket system on the planet, bar none, any architecture from any vendor. We will have leadership. We do have leadership benchmarks that we've published. I'm not going to go through them all today. If your teams are interested in them, we'd be happy to talk about them. But fastest 4-socket system on the planet. Just to put it in perspective and have a little fun with the competition, I know that there's been a lot of buzz in the industry about the Niagara systems from Sun and the T2000s. Well, if you want to do a little server consolidation in your shop, and we've looked at based on utilization for many of you in this room and others around the world, look at those T2000s, how they're utilized. If you want to do a little server consolidation, especially leveraging IBM's virtualization technology, we think you'll be able to put 92 of your current T2000s onto one of these 750s. So a little bit of a consolidation ratio, if that interests you. And again, to have a little bit more fun with our friends at Sun, now Oracle, if you look at all the T2000 shipped since they introduced this product in 2005, there's been more than 91,000 of these. If we're making the offer, we'll consolidate every single T2000 ever shipped on the planet into 1,000 of these 750s. And along the way, we're going to save a few million kilowatt hours. So again, just to put things in perspective, that this system is quite a bit more capable and quite a bit more efficient than the competition. This is an efficiency statement, again, head-to-head with some of the leading competitors today. So when we measure efficiency, we look at performance per watt, how much work you really get done per watt of energy utilized. And when we look at work per watt, we're way ahead, and we intend to stay ahead. Let's pick on another competitor, since I like to have fun with competitors. You're all familiar with HP's Integrity Superdome. So if you look at a fully configured 64-way high-end Integrity Superdome of today, and we'll look at the, drawn to scale, a Power 750. And you look at how much wattage is needed to run this system, 11,500 watts. And we looked at one measure of performance, look at spec int rate. This one rates out at 824. 1,950 watts to run a 750, spec int rate at 1060. So, if you want to save 80% on your energy costs and run your workloads 28% faster, obviously you'd move to a 750. And the joke, of course, Superdome or Superpower. Obviously, I'm going to vote for the Superpower. Hopefully, you will too. One benchmark, again, I'm not going to go through all the different benchmarks, but one benchmark that's interesting globally these days, used by many people, is the SAP SD2 tier. It's a real application benchmark. It's not a technology, you know, how fast is your integer performance benchmark. It's kind of a representative real world SAP benchmark. And this 4-socket 750 and its performance of 15,600 SD users at one time puts us in a class by ourselves. Clearly faster than any 2 or 4-socket system available, faster than any 8-socket system available, almost as fast as a 32-socket M9000. And if you know the price or your cost for an M9000, you know there's an order of magnitude difference between the cost of a 750 and an M9000. So again, I think we're putting the industry in a different perspective now with these smarter systems. The next set of systems that I'd like to introduce would be the IBM Power 770. Again, another sexy black box. The 770, think of the 770 as the follow-on to the 570. Today, the 570, the Power 6 570, is the most successful mid-range Unix computer ever. It is the dominant player worldwide in the mid-range Unix market. It runs more than Unix workloads, but that is the main part, the sweet spot of the business. It's been a global phenomenon, quite frankly. And the 770 is the follow-on to that product. It's in modular design. It is a new design, but it's the same modular design as that you could put 1, 2, 3, or 4 of these systems together and run them as a single SMP. It's a lot more capable, given that there's 8 cores per chip now in terms of performance and capacity, and there are features such as capacity on demand and enterprise RAS features built into it. Another product we are announcing today, I don't have one up here on the stage, I'm sorry to say, but that is built on this 770 building block is this new model that isn't in our product line today. It's called the 780. It is a higher end version of the 770. There's even more performance that you can get on it, so this will be our highest performing mid-range computer. There's more enterprise RAS features for you. There's 24/7 warranty, power care services. Again, so we've just, by introducing this set of computers from, you know, a 4-socket 750 up to this very large capacity 780, we've introduced the middle of the product line, and we've given you a lot of different options for your computing needs. So again, to have a little fun with the competition. So if you want to take 8 of those 77-inch wide and 77-inch high, 30-inch wide, 64-core Integrity Superdomes, you could take 8 of those and put them into just one of those 780s. So there's consolidation opportunities and leveraging virtualization technology there for you to really make a difference in your IT infrastructure and your cost structure. And speaking of costs, many of you have talked to me about granularity, so I'm going to go to a different spot here. So with that 770 and 780, one of the things you can do is you can do capacity upgrade on demand. And some of you have said, I just have peak times during the month or during the quarter where I want to turn on some capacity and I want to turn it off. You've also said to me, I'd like to be able to add some temporary capacity because I need to test out a new application. I want to try it before I actually, purchase capacity and commit to it full time. So just to put it in perspective, with these new systems, for 15 pounds a day, you can turn on one of the engines and a Power7 chip and up to 8 gigabytes of memory, and through virtualization, create yourself a server. Very cost-effective way to turn on some capacity. And by the way, you can turn it off because you're going to be charged by the day. So you want to turn it on for 3 days a month just to have it for part of a cycle, that's fine with us. So I think we've, again, redefining some of the dynamics and cost points and capabilities and giving you flexibility in your business to meet your business needs, your business challenges. Another perspective, and again, some of you in this room have pointed this out to me last year saying, my procurement office is just focused on cost of acquisition. And I'll just be honest about this, when I look at these new Nehalem boxes, the cost of acquisition is so much lower than PowerOS. Well, okay, let's reset everything you know and have thought about last year into a new perspective. So here's this is a real-world workload sizing. So this is off an SAP sizing. It happens to be 110,000 SAPs. Here's exactly the hardware you would need if you would go out and buy an HP ProLiant Nehalem EX set of boxes. Those are the boxes that you would need to hit those 110,000 SAPs. And here's the IBM Power 7 boxes you would need to meet those SAP $110,000 SAPs, and the cost of acquisition for the hardware and the operating system, that's it. Acquisition cost, hardware and the operating system, 13% less for the Power Systems. So those of you that think that it's cheaper to buy the stuff from the other guys, I'd ask you to think again. There's a new cost equation here coming out with these systems, and I think it's going to resonate around the world. The clients that I've talked to already earlier this week have really found some profound statements in here, and I hope you will take that away as well. So generally, the way to think about these new POWER7 systems, if you're a Power6 customer today, and thank you if you're a Power6 customer today, most of you are, this is the way to think of it. You're going to get 4 times the energy efficiency, so 4 times the energy efficiency over Power6. You're going to get twice the performance over Power6 for the same price you're paying. We think that's a pretty good deal, and we think you're going to find it valuable in your infrastructures. Rounding out, that's the hardware piece. We continue to move up the stack. Hardware's not much without operating systems. So POWER7 continues to support all 3 Tier 1 operating environments as we do today: AIX, IBM I, and Red Hat and SUSE Linux. All are available as we speak this quarter, and you can run your current levels of your operating system. So AIX 5.3 and AIX 6.1 just move over here. IBM I 6.1.1 and Red Hat and SUSE the same thing. You can move your current workloads over. You don't have to go to a new version of an operating system to begin to take advantage of the capabilities of POWER7. Now, in that software stack, the hypervisor and the virtualization, the management layers are very important to you getting full value from these systems. So I'll just quickly go around the 4 areas outlined on this chart. From a virtualization point of view, we continue to push the envelope. In Power6, if you remember, we used to talk to you about it's okay to push your utilization up to 60 or 70%. Many clients around the world are already running their Power6 systems at 90, 95. We have several running at 99% utilization, even though we didn't recommend that. Well, now we're recommending go ahead and drive your systems up to 90%. We're that comfortable. You want to run 10 LPARs, 20 LPARs, 100 LPARs, or the mid-range and high-end systems will now go up to 1,000 LPARs if you really want to get crazy and wild with the amount of virtualization you do, and many of you do. Many of you do. That is a requirement that was clearly stated. We want more than 254 LPARs, which is the maximum number on Power6, so now you can go up to 1,000. But you can trust your business on this rock-solid virtualization technology. Resiliency without downtime is another theme that we've been on for several years, that I've been on for several years, because you've told me I need continuously available applications. So we're making another step in that roadmap today. And we're basically doing 2 things to help you get to a point of having continuously available applications, applications that you never have to take down. And that is, we're doing it through 2 ways. One way is through we continue to make it more and more in the entire hardware, firmware, and OS stack that you can do change management on the fly. So you can change the hardware on the fly, you can change the you can update the firmware on the fly, and you can update the operating system, including the operating system kernel on the fly. Now, some of you have told me, okay, that's interesting technically that you can now begin to approach 100% total uptime for your hardware and software, Ross. We don't really trust you, and some of you actually say it quite like that. Even though we think it might work, we still want to be able to protect our applications. So through the mobility of virtualization, you can move your live running workloads from one physical IBM POWER7 processor to another, right? So using live partition mobility. So again, on our continuous availability roadmap, another big step here towards giving you that continuously available applications. Talked a little bit about dynamic energy optimization. We think it's world-class what we have in here. It's not just the hardware. Again, it's instrumented through the software with our patented and trademarked energy scale technology. And finally, from a management and automation point of view, through a single easy-to-use GUI interface in the IBM Systems Director, we're bringing together all of our management technologies, integrating them and allowing you to set up, configure, manage, monitor, do reporting through a single interface of the whole stack, including all the virtualization. There's things like VM control that's listed up there on the chart. That's a new feature that allows you to manage pools of virtual resources, not just on one physical KEC, but across any number of systems. So again, making it easier, less costly, much more simple for your administrators to set up and run these systems. We know that that's important to you. So, giving you a perspective from the micro to the hardware to the operating system level, that we've done full integration, design and development and testing on that. And now I'd like to bring up my colleague, Robert LeBlanc. Robert, who runs IBM middleware. He's going to talk about smarter software. The software group has been working for over 2 years with the systems group on integrating the design and taking advantage of these massively parallel amount of threads. So Robert, please. Oh, I'm sorry. Oh, I jumped ahead too far. Sorry, I got to back up. I'm going to start again, reset. Sorry. So Christopher Hale, who's going to come up and talk to you about virtualization, and then Robert LeBlanc's going to come up. I'm excited about Robert coming up and talking. And it's not that I'm not excited about you, Chris, I'm sorry. But come on up here for a second.
Thank you.
But to have a senior vice president from the software group with a hardware guy, I feel pretty good about that. Anyway, Christopher, sorry about that. You're going to give us a little bit more detail about the power of virtualization.
That's right.
Thank you.
What a great introduction. Thank you. So, yes, I'm actually Christopher Hales, and I'm a power systems architect in the UK and consulting IT specialist. And I'm going to talk to you now about two things. One, I'm going to talk to you about the POWER7 processor and systems technology, and then I'm going to use that as the backdrop or the context to talk to you about re-examining some of the fundamental virtualization characteristics that we can exploit in the new POWER7 era. So you've probably heard already that we're moving now from 2 processor cores per chip to 8 processor cores per chip. Now this really does give us a huge increase in computing potential. And we've got to realize that potential, and we realize it by pumping as much data and instructions into those cores as we possibly can. And that keeps them busy doing real work for us. If we can't do that, what happens is that they just spin, they burn up energy, costs us money, and we don't get the utilization we need. So we need to engineer the chip and the whole system to make sure that we pump that data and instructions into the cores. And this plays to IBM's strength in the industry, because we don't just design good microprocessors, we design it with a holistic view to the whole system. The whole system has to make sure we keep that data and instruction pumped into those engines in the microprocessor. And I just want to draw your attention to a couple of things that we've done here. One is that we've moved all of the cache right there onto the processor chip. All of the cache right on the processor chip. And that means it's physically close to all of the cores. So it's there ready, the data's there ready to pump into those cores when it's needed to do that. And we do something else that's quite clever with this cache, is that we use quite a lot of heuristics on it. We physically move the data around the cache to make sure it's closest to the cores that it needs, that need the instructions and data. So we're constantly optimizing and then re-optimizing the caching that is going on the POWER7 chip. Well, of course, those caches need to be flooded with data and instructions as well from the memory subsystem. So we've had to engineer a high-performance memory subsystem for POWER7 servers. So we have an absolutely tremendous amount of memory bandwidth that comes in and floods those caches with the instructions and data that we need to drive those cores. Now, the other thing I want to mention, and doesn't get mentioned too often, I don't think, is scalability. Now, when you buy a processor, an extra processor, and you put it in your machine, you'd like a whole processor's worth of work to be done. You've paid for the processor, and you've paid for the license of the application software for that processor. So you want a whole processor's worth of work done. And this is where scalability comes in. The design point for POWER7 is 32 sockets. So 32 times 8 is 256 cores in a single server. Now, in order to be able to do that and get that value from those extra processors when you plug them in, you have to have a tremendous amount of SMP coherence capability. And that's, again, something we've built into the POWER7 chip and right throughout the system. It's huge amounts of SMP coherence bandwidth. So that's the engineering sorted out. But we didn't want to stop there. We wanted to actually innovate quite a bit across the chip and across the systems. And I just want to bring a few of these to your attention right now. So on one of Ross's charts, we saw Turbo Core. Turbo Core is where we select a few of the cores and we increase the clock frequency quite significantly for those cores. And then what we do is we increase the ratio of cores to cache on that particular chip. And this favors transaction critical workloads, so it's specific and tunes to that particular kind of workload. Whereas Max Core, on the other hand, has the full threading capability of all of the cores, and that tends to favor perhaps more parallelized workloads. Typically HTTP serving, web-facing type applications is a good example of that kind of thing. Ross also mentioned that we have threading capability on each of the cores. So each of the cores will handle 4 execution threads at the same time. So that's 32 threads for each of the POWER7 chips. Now, threading of that nature benefits most workloads, but not necessarily all of them. And so what happens with intelligent threading is that the system and the chip is constantly addressing whether or not this threading approach is delivering the most throughput for this particular workload at this moment in time. And if it doesn't, it will adjust the threading capability for that workload through that particular core. So that's intelligent threads. I've already mentioned intelligent cache, and we've got some, well, I've got some information about intelligent energy optimization. But again, to reiterate what Ross was saying, we have a fantastic energy story to tell there. So as I move out a little bit further into the system, we have active memory expansion. So what this is really it helps you with a dilemma. As you run a system, keeping the ratio of memory and processor capacity in line and in that sweet spot all of the time, particularly as you're tasking and retasking particular partitions on it, is quite a difficult task over a period of time. And this is where active memory expansion comes into play. What it does is it compresses the data and instructions in the physical memory so we can get more into it. We drive up the utilization of the physical memory in the system. And that means we can have a server, let's say it has half a terabyte of memory in it. It actually behaves as if it had 3/4 of a terabyte of memory in it, perhaps even as much as a terabyte of memory in it. And you can adjust this and keep the server in that sweet spot of processor and memory as indeed you start to retask some of those partitions. And the last point I wanted to make on this slide is that even say 2 years ago, applications that required the extreme I/O capability of solid-state drives were fairly uncommon, but they're becoming more and more common now. And so what we've made sure with these systems that we've announced today is that solid-state drives are right there in the chassis of all of these systems so that you do have applications with extreme disk I/O requirements. We can satisfy them with each of these servers. So these are powerful servers and they're efficient. But where does that leave us in terms of the virtualization? So let's do a little bit of a comparison of 2 cores versus 8 cores with virtualization. So here we have, in POWER6 terms, a 2-core socket with a 4-socket system. That's about 8 cores. Is that typically virtualized? Well, many servers are virtualized with some partitions on, but also many servers at 4 sockets are not virtualized. They're a single partition running a single workload, could be an application or perhaps a database. But as we move up into the higher core counts of servers, such as 32-core servers, or even at the top end, which is the 64-core servers, what we find is that these are significantly more virtualized, significantly more partitions on these. And the higher the core counts, the more virtualization that takes place, because you get a very significant amount of benefit by virtualizing. Now let's move forward into the POWER7 era. So our humble 4-core system here in 4U now goes to 32 processor cores in that system. So is that likely to be virtualized with many partitions? Yes, I think it really is. I think there's going to be lots of partitions on just the 4-core. And as we move up into the 64-core areas with the POWER780 and the POWER770, yes, that's all going to be fully virtualized as well. And then we go to the ultra-scale machines, the 256-core machines. I think those are going to be fully virtualized. I colloquially call those sort of cloud in a box type machines. Many, many partitions fully virtualized on those sorts of systems. So the point I'm trying to make with this slide really is that in the POWER7 era, we're likely to see pervasive partitioning and virtualization of these machines, even down onto the 4-socket types of server. So how many partitions are we going to support on the servers that we've announced today? Well, right now, today, at this moment, we support 160 partitions on all of these servers. So even on the 750 Express server, 160 partitions. But according to our statement of directions, that is going to change very soon. And we're going to support many, many more partitions on these servers. So on the Power 780, we're going to support 640 partitions. Same on the Power 770. And on the Power 750 Express, we're going to support 320 partitions. Hundreds of partitions on a 4U 4-socket system. So it's probably worth us just re-examining then a bit about partitioning technologies. So as you know, IBM implements logical partitioning. What we do is abstract the critical resources. We group those resources together, a little bit of CPU, some memory, some I/O capability into a partition. We can boot an operating system, and we can run an application in it. And because it's logical, of course, we can adjust the resources we're using, and we can change those dynamically to whatever shape we like to fit our needs right now. Again, retask things later if we need to do that. And that gives us some advantages. It's much more flexible. We get better utilization out of the machine. And of course, we get some agility there. And we've had this technology in Power Systems, I think, since 2001. And then in 2005, we introduced, in my opinion, a step change. So we still have logical partitioning technology, but in this particular case, we introduced the capability where we could get the processor capacity from a pool of processors. So what we could do here was define very precisely how much processor that each partition could have. So we can get as many as 10 logical partitions per processor. So we're starting off with 1/10 of a processor and expanding right up into the top of the machine if we'd like, with very fine granularity. And that means we get better utilization out of the machine. But to me, the biggest advantage of this would be the system would look down its partitions that it's running right now. And of course, some of those partitions are going to be busy, and some of those partitions are going to be less busy. And the system then harvests the unused processor, and it gives it to the partitions that have got real work to do. It gives extra resources where the work is. So it focuses the processing capacity on the work to be done, the value to you of the work to be done. And so in this way, we can significantly drive up utilization of the server. And that has some dramatic effects. You get more work done for the investment you've made in the server. You get more work done for the software investment you've made in licenses. And you get more work done for the energy that you've consumed. So a big leap forward. But we deploy servers typically in groups. And when you've got hundreds of partitions on a particular server, it would be quite good if we could group these together, because we typically group together partitions to deliver services to sales and marketing, or perhaps HR, or perhaps manufacturing. And so a few years ago, I came up with a set of specifications, an overall design for a way in which we could do this. And then I worked with 2 of IBM's distinguished engineers over in Rochester Development Labs to develop the idea. And we've filed patents in most of our major markets. And we've implemented this kind of technology in the autumn of 2007. And what happens here is that for each of the groups of partitions that are defined, you have a specific amount of capacity. Let's say it's 20 processors. And within that group, unused capacity is harvested, and it's given to busy workloads inside that group. So each group is optimized for its particular set of partitions. And that gives us a number of advantages, not least of which, of course, is manageability. You've grouped together the things that need to be grouped together. Accounting and billing is very useful, because you can, of course, have these, if you're an outsourcing company, these could be contracts, customer A, B, and C. Or, as many of my customers do, they define a group that is, say, database software. So they license their database for 20 processor cores, and then it is constantly optimizing the throughput of traffic for those databases. They drive up the utilization that they're getting for the licenses that they've purchased. And sometimes they make very substantial savings in this area. Now, if we can do this for hundreds of partitions on a particular server and get quite a lot of advantages and benefits, wouldn't it be great if we could do this for an estate, for a group of servers? And that's exactly what we can do now with VM control and by leveraging some of our technology in live partition mobility. So we've now got a system pool, a group of servers, fully virtualized with lots of consolidated workloads on it. And then with live partition mobility, we can start to move those partitions around the estate, depending on the kind of policies that you want to have in place. Now, that doesn't preclude us from tailoring and focusing some of that estate for particular workloads. So one or two of those servers, of course, could be in turbo core mode, handling those transaction-critical workloads. You can have analytics, you can have web-facing applications, and a set of policies that are moving around those partitions to optimize and re-optimize the whole estate all the time, making sure that you are optimized for performance or service levels or energy. So that's probably a good sign for me to start to talk to you about energy then. Now, Ross has said already that we've got a great story here on energy, and what I'd like you to take away from this particular slide is the top line here. So POWER7 delivers 4 times the performance than POWER6 for the same energy. 4 times the performance for the energy. Just let that sink in for a second. Now, not too many years ago, I developed a strategy for IBM for 3,500 Unix servers. And I would typically look at what I'm going to re-platform this year, or what are the committed projects for growth this year. And if I was doing it now, I'd probably look a little ahead into the growth of the economy, hopefully, in the next 2 years. And I'd be a bit ambitious. And I'd say, right, I'm going to grow the compute capacity of my estate by 100%. I'm going to double it. But also in that period of time, I could probably halve my energy consumption if I was using POWER7. I mean, that is dramatic step change difference in energy usage. So this isn't your 10% better or your 20, 30% better. This really is quite revolutionary in its capability for energy optimization. And there's a multiplier effect with partitioning. When you partition and you drive up the utilization of the server, you're getting more work done. So you're getting more work done for the incredible energy ratio that you're getting already. So it's a multiplier effect as well. And that's before we do anything intelligent with our energy scale technologies. So let me give you just a quick couple of examples with energy scale. So if we are anticipating the workload, we can tell if a particular processor core is required. And if it's not required for a short period of time, we can send it off to have a bit of a snooze. We call it nap mode. And it goes to sleep for a while, and it saves us a little bit of energy. But of course, we can wake it up quickly when it's needed. If we can predict that it's not going to be used for a little bit longer, we can send it into a slightly deeper sleep and save even more energy. And again, we can reinitiate that and bring it up very quickly. But by doing intelligent things right through the processor and through the systems, we can save more energy as well. And all of that is orchestrated through IBM Systems Director. So let me just begin summarizing then. So I think, and I hope I've given you a flavor of just how breathtaking this technology is. I've been very fortunate over the last 18 months, 2 years. I've actually had meetings with many people in our Austin development labs in Texas. I've met with the chief POWER7 engineer and his team, the chief cluster architect and his team, software engineers, systems designers. I know a great deal about the technology. And by the way, if you'd like me to come to your organizations and tell you in detail about all of this, I'm more than happy to do that. But realistically, I think to myself, you know, this is a step change in the technology. And POWER6 was no slouch. But then we also add on top of that this new era of virtualization, hundreds of partitions on even a 4U, 4-socket system, with the energy efficiency and the ability to start moving around partitions in an actual state to drive certain policies that we have. I think we are coming very close to virtualization without limits. And what I actually like to call, colloquially, infrastructure homeostasis, where it's similar to the way an organism reacts to its environment. Now that's a bit far, I know, but we are getting towards that sort of automatic way in which we can optimize that estate and continually re-optimize it for the workloads that we're running right now. Okay, thank you very much indeed for your time and attention this morning. Let me ask the next speaker. Thank you very much.
Thank you very much.
Thank you.
My poor introduction of Christopher, hopefully you got to see, get a glimpse really of the power of the virtualization technology, what it's really matured to now in these systems and what you can take advantage of. And even though I gave him a great introduction before, I'll do it again. Robert LeBlanc, Senior Vice President, IBM Software Group Middleware. Robert?
Thank you, Ross. Good morning. What I want to talk about this morning is really, as Rod and Ross and Chris talked about, the stack. Because what's really important here is that we take the software and you really exploit the hardware. You know, in computer science, we haven't come up with hardware that doesn't run with software or software that can run without hardware. And, you know, the way you make them work together is really, really important. And that's the step change that I really believe we're looking at here with POWER7 and some of the things that we've done with software. The other thing that's important is as we were designing POWER7, it was not just about the processor and the box, but it was also about the software. So we had software engineers from our software business as part of the team so that we could influence the design and take advantage of the active memory, to take advantage of the threading model, to take advantage of the virtualization and the workload management capability and integrate that. And that's a little bit what I want to talk about here this morning. Because as we talk about smarter systems, you know, you need smarter software. So this is not just about the box, this is about the system. And why is that becoming important? Because as the physical world meets the digital world, the workloads that we're all going to be faced with are dramatically changing. Some of them are just exploding in terms of the amount of data and velocity that we need to deal with. You have the insights, the analytics that you want to apply on that data. All that data is great, but if you're not learning from the data, if you're not adapting your enterprise, you're not adapting your business processes, you're missing an opportunity. So with the gathering of data, you've got to be able to analyze. That is taking a very different kind of workload. And then the number of transactions and interactions that we have is increasing as well. So we've got to be able to optimize for those kinds of workloads. So the workloads are changing. The requirements on those workloads are just astronomical. And therefore, we've got to start building systems from the hardware all the way up to the software, the middleware, that can take advantage of that. And that's where we've been focused. So we've got our middleware products, and you all know our middleware products from DB2 to WebSphere to Rational and Tivoli. And we run across, you know, a various set of hardware platforms. But we really spent a lot of time taking our software and optimizing it to POWER7 to take advantage of some of the features that really are unique to POWER7 and really enable us to step change the kind of performance that we can give to the systems that you run. The applications, whether they be database or CPU intensive. And we'll talk a little bit about that. So it's all about lowering the cost, faster time to value, and better performance. A couple of interesting things here. As we go to this level of parallelism, parallelism's been around the industry for a number of years. We've seen it in the scientific area. We've seen it in universities, these large-scale parallelized systems. We've never seen that level of parallelization exploitation on the commercial side because it's hard, because you had to take and restructure the application. Well, what we've done is we've effectively parallelized the middleware to take advantage of all of these threads. And now that enables the applications and all of these business things that go on like queries to take advantage of that. So you're getting the power of parallelization without having to go back and change your applications or go and hire a whole new set of experts in your application team that understand the nuances of parallelizing a business process and application. And we're starting to see near linear scalability. In the past, the more processors you added, the higher the cluster was, we saw a drop off. Well, with some of this new capability, we're now starting to see linear scalability. So when we talk about scale up, some people look at this box as a scale up box. I also look at it as a scale out box, because we're taking advantage of the capability in the software such that it behaves very similar to scale out. And that's some of the things we've been working on here with the team. So if you look at, what do I expect? Well, here's just some data. This is a WebSphere application server, okay, running against a competitive application server. And we're running on top of POWER7. We're taking advantage of an 8-core system and all of the threads. We can now, in a JVM image, drive it up to almost 4,000 transactions a second. In comparison, if I was running on an Nehalem 8-core system, a similar system, I'm running about 2,000 transactions a second. So we've seen a 73% more work now that I can drive. It also is a simpler configuration, and it drives better utilization and scaling of that application server. And so we're building that right into what we do with the WebSphere application server, because we're exploiting the capability in the threads. The other area we're focused in on is messaging. And as you know, as we build out these distributed systems and we now start to scale with the internet, the managing of messaging is becoming absolutely critical. And a lot of the systems we built are very message intensive. So here's an example of running our MQ, our message broker product, on top of Power 750 with the 8 cores again, and comparing that to running on Microsoft's BizTalk technology and SQL Server running on a Nehalem. And you see the difference. 53 times more messages a second. We can drive 21,000 messages a second versus driving 409 messages a second. So you're starting to see a level of scale here that is pretty substantial on the box. Because what's happening is we're taking advantage, again, of the hardware capabilities and the virtualization capabilities, changing the software to drive better performance. Now, you saw SAP, a lot of SAP systems out there, we're working very closely with a lot of clients. We also work very closely with SAP. We actually have one of our design centers in Mannheim, in Germany, that's co-located with SAP. So SAP influences a lot of the decisions we make in terms of DB2 and the database. We, in turn, influence a lot of decisions that are made down by the engineers that are building out the Power Box. So here's an example. If I take the number of users I want to support on a Power7, I can compare it to a 32-core Power7, compare it to a 32-core Oracle on UltraSpark, over 3 times more users I can support. Even if I go over and take a look at a 48-core, now I'm comparing 32 to 48, a 48-core AMD Opteron system, I'm still 60% more users that I can support. Now translate that into cost per user, because we know that's a big factor in a lot of decisions that get made. You can see the cost, down to 61 pounds per user on DB2 running on Power versus Oracle running either on a Sun UltraSpark or a Sun on an Intel processor. So this notion of Intel's cheaper, I think we're really dispelling here with this level of performance that you're seeing. And obviously, if you're an SAP user, that can translate into an awful lot of saving, because it saves not only a cost per user, but all the other things that go into the total cost of ownership. The other thing that the technologies enable us to do is we've come up with another product called DB2 PureScale. And this really is for that extreme level of scalability when I'm dealing with a lot of clusters. Now, in the past, we really hit a limit, and then performance would fall off. Hence, you look at the bottom chart. This is Oracle's rack which everyone talks about and the press writes about and the trade writes about, on an Nehalem. So it's the latest and greatest from Oracle on an Nehalem. Compare that to DB2 Pure Scale running on POWER7. And you're starting to see the scale. What I find really interesting is you notice when we go out there to the extreme in terms of the number of cluster members, we're not falling off. Take a look at what happens in a typical system in the fall off. Look what happens as we continue to scale up. So you really are starting to see linear scaling here that we've never been able to see before. And that really enables that scale out. So we talk scale up, this really example of scale out. And we've been able to, again, take advantage of the capabilities that have been built into POWER7 to get some performance that we've really never seen before, especially in a single system. Now, the way we look at this from a software perspective is we take advantage of the intelligent threads, and you heard the discussion around Turbo Core and Max Core. And that was a great example of the hardware engineers, the operating system team, and the software team, in this case DB2 and WebSphere, really coming up with a concept that allows us to, in real time, tune the system. And what we've done is we've been able to match the workload manager that comes in our DB2 and WebSphere product and integrate it with the workload manager that comes with the operating system and with the virtualization control, the VM control product. So now that is a much tighter integration and passing on a lot of information. Just doing that, look at the lower cost that this drives. Lotus Domino. Now, we didn't have to do anything to Domino, okay? Because Domino sits on top of WebSphere and on top of DB2. We embed some of that technology in Lotus. So here's an example of an application, and this could in turn be any application vendor out there. 40% lower costs because we can now drive many more users and higher application utilization on a Power system than we can, in this case, Microsoft Exchange versus Nehalem. So the value you see is going to go all the way up to the application vendor. From our perspective, there's going to be value for you on your whole IBM stack, software stack. This is just a partial list of the products that embed DB2 and WebSphere application server today that we deliver. Every single one of these applications gets the inherent performance that we see out of our middleware that we've tuned to the POWER7, and in turn get the real value of POWER7 and all of the inherent characteristics of the performance. So as an example, the SAP BW benchmark, which really is to represent a real workload on SAP, 40% performance improvement. And you're starting to see that in the applications themselves. 6 times faster performance in data-intensive applications. That's because we can take advantage of the Max Core and the Turbo Core. Again, build that into the database such that the application inherits the characteristics and the performance gains of the middleware. So that, I think, is really important. We're seeing it in our storage manager product, Tivoli, that does storage management. Well, we can improve the data deduplication that goes on and take advantage of that power, and we see 40% improved throughput versus Power6 running on Power7. Same thing with managing of events, 40% improvement. So you're seeing this not only inherent in the middleware, but anything that sits on top of our middleware is inherently going to get that capability. Now that shows up not only in our WebSphere and database products, analytic products, but it also shows up in other parts of the portfolio. In application development and maintenance, we've got a new set of products that we have targeted for Power7 so that you can start to build applications that can now take advantage of the capability being built on top of Power7. We think that can lead to as much as a 20% improvement on developer productivity. And we all know that the labor costs of developing applications is extremely high. We've also seen up to 40% more efficient throughput here in systems management. And we all know systems management can provide us a tremendous amount of value, but we're always worried about the overhead of what does systems management cost us. Now we can bring down the cost of systems management and the overhead it has on your systems by up to 40%, by again taking advantage of some of the underpinning middleware exploitation of the threads and virtualization in POWER7. So this is not only about the middleware, but everything that's associated with it gets the value up the stack. And as Rod and Ross both said, it's about up the stack. The other thing you're going to see us do, and we started late last year, is we're going to start to integrate the pieces. So here's an example of our smart analytics appliance. What we're doing with the smart analytics system is we're going to take a POWER7, we're going to take some of the DB2 capability, we're going to take Cognos capability, and we're going to integrate it in the box. So what you can do is now you are data load ready. You load the information in, and you have already a system that is ready to deal with all of that data and provide analytics on all of that data and information that you had. You can deploy now in 12 days instead of 6 months. Because the value is what you get out of the system. Okay, it's the outcomes and the insight that you get that's important, not putting all the pieces together. So here's an example of us now providing much more of a stack. And you can anticipate that you'll see more and more of this as another way to deliver capability to all of you as our clients. Now, I had an interesting discussion last night at dinner, and I actually put this chart in at the last minute. It's a chart that we use, and people talk about scale out. Well, is this a scale out versus a scale up? Well, I think virtualization has really changed the game, and it's actually both. And what we did, this is a benchmark that we run, and it's 45 workloads of WebSphere, and it simulates an online banking workload that we use that will drive 745 transactions per second. So each instance runs 745 transactions. So this is really the scale out. And people talk about the total cost of acquisition. Sometimes we talk the total cost of operating, and we add in all the operating costs. But as we know, a lot of the procurement teams want to talk about TCA. So we looked at the TCA. To run those 45 workloads, you could buy 45 8-core Nehalem servers. You could buy 2 32-way POWER750s, or you could run this on a POWER770. What's really interesting is when you start to look at the cost. The total cost of acquisition. You want to go and buy all those quote-unquote cheap Intel boxes would actually cost you more than acquiring a POWER750 or a POWER770 to run the same workload and get the same level of performance. So if you want cost, this level of scalability, okay, and exploitation, you know what, is also changing the cost dynamics. So, in the discussion I had is, you can scale out. That is not necessarily the way to save money, because you can scale out and scale up with the POWER7 box because it gives you the capability to do both. So we're really committed here from a software perspective to take advantage of the virtualization and consolidation capability, okay, to help consolidate workloads, drive fewer instances, drive the cost down of not only hardware but software. And we do that because we take advantage of the capability that's inherent in the Power, the workload management and the tight integration of workload management. You can have all of the pieces, and Oracle and Sun are out there talking about the integration of the box, and Larry talks about he wants to be IBM of the 1960s. Okay, you can be the IBM of the 1960s, you're only 40 years behind, right? The key is you can put all the pieces together, but if you don't exploit what's there, you're never going to get the true power of an integrated system. Like I said, we spent the last 3 years working with the POWER7 team on making sure we had a totally integrated and exploited software and hardware system. So, those out there in the industry can start now. It'll take them several years, to get to the level that we've been able to do. the reduction of memory footprint, the exploitation of active memory, end-to-end resource management. These are all things that we took advantage of, and we actually helped drive some of the changes. So from a software perspective, we've got this kick-ass box that provides a level of performance that no other combination of middleware and hardware can provide in the industry, bar none. There is no one that can provide that level of performance and drive the cost down. So you're getting cost and performance. And we do it across all of our portfolio. So whether it's Lotus or Rational or Information Management, Tivoli, all of the portfolio gets to take advantage of the work that we've done here across the product line. Because at the end of the day, from a software perspective, what we're looking to do here in conjunction with the POWER7 team is drive faster time to value, better performance, and do it at a lower cost. So when you really think about what we've done here, it really is fundamentally changing some of the rules that we've looked at in building systems and integrating systems in the past. So I'm pretty excited about it, and that's why I'm here, because I really wanted to make sure you all understood the step change here that I think we're bringing to the market and the level of integration between the hardware and the software that is going to make this thing a very unique value proposition for all of you to be able to drive your businesses, which is the most important thing for us. So with that, I want to thank you for your time and attention. Ross, thank you for allowing me to be part of this great event.
Thanks, Robert, very much. Thank you. I think I found someone as excited about POWER7 as I am. That's great. So, all right, so let's go to the next step in our agenda here. I'm going to bring up some of our clients and partners to give you their perspective on power systems and this breakthrough technology. So I'm going to invite 5 folks up here. First, I'd like Kyle Ortega, who's the Global Head of Communications for eMeter, to go up and join us. I'd like Jonathan Fellows, who's from Darsbury Labs, who's the Distributed Computing Leader, to come up and join me on the stage. I'd like Craig Williams, who's the Global Head of Unix and Storage for Barclays Bank, to join me. I'd like Nick Cummings from Parker Hannaford to come up and join me on the stage, please. And I'd like the CEO of Integration Systems, a solution provider and business partner of IBM, Terry Keane, to join me on the stage. So, I've been hearing a lot about the technology and the benefits. So Kyle, eMeters have got an important niche in a dynamically changing industry. How is power helping your business, and can you please give everyone a perspective on the explosive change going on in utilities?
Sure. So just a quick sketch. eMeter is essential software for smart grid success. We provide basically a middleware that allows you to drive business value from the millions of new meters that are coming into place, the grid devices, in-home devices that are being installed. Right now, 32 countries have over 215 million meters underway. We believe that will grow exponentially. One of our joint customers in Ontario currently is in the middle of a 4.5 million meter deployment, where they used to read the meters, as Rod discussed earlier, once a month. Now they're reading it 24 times a day. So you can imagine the explosive data that's taking place. I mean, one of the things that we often say in our industry is that Thomas Edison could still come back to the electrical grid and completely understand how it works. Telco went through such a transformation that Alexander Graham Bell could come in and have absolutely no idea what he had discovered and where it still sits. And that's kind of what's taking place in the utilities today. Utilities are dealing with so much data that they're going to need systems like POWER7. We did performance testing on POWER5, where we were able to map 5 million meters against the POWER5 system. On POWER6, we were able to do 4x that, so we had 20 million meters. And we expect when we do performance testing on POWER7 that the 4x return will be similar.
Great. Thanks, Kyle. Interesting perspective, again, on an industry whose business model is changing and clearly driving the need for smarter systems. So, Jonathan, tell us a bit about Darsbury Labs and what you're experiencing from a high-performance computing point of view.
Well, to put it in context, we're part of an organisation called the Science and Technology Facilities Council, which is one of the UK research councils, which collectively fund academic research. And the F in facilities really means that our role is to provide facilities that are usually bigger than universities themselves want to provide. So we have synchrotrons, light sources, and we pay things like the UK's subscription to things like the Large Hadron Collider. My department, the department I'm part of, is the Computational Science and Engineering Department, and we have a plan we're setting up a new centre at the moment to deliver science and step change science through enhanced simulation on computing, so high performance computing for sure. And the world is changing very rapidly, and we need to keep up with that, I think. I mean, to put that in context, I was responsible for putting in the HPCX system, which was a national HPC service, which was decommissioned last week, in fact, which was an IBM POWER7 system. And when it was introduced in 2001, it was capable of about 3 teraflop, 3 tera floating point operations per second capability. 40-plus racks, was the 9th biggest system in the world. I've just taken delivery of 4 of those boxes on Monday. I think collectively that'll get us 3 teraflops. And needless to say, it won't be anything like the 9th biggest system in the world. But the challenges are on really how to make use of the new technology, and particularly multiple cores, and how the applications can scale to use the new technology.
Great. Thank you, Jonathan. So, Craig, I know you've been a strong supporter of power in Barclays Global Business. Can you give us a perspective on how that's affecting your business and where it's going?
Yeah, no problem. We've been a big user of power systems, going back to where Rod was kind of pointing out on the chart, kind of from the early days. I think what's excited me more so than ever is probably if we look back the 4 or 5 years. I mean, it's a great time to work in financial services, as everybody's seen at the moment. But what we've seen certainly with power systems is more and more what I would call mission critical applications. Our tier 1 and tier 2 services started to be hosted on power. And we continue to tick all the boxes around stability, availability, kind of reliance of these kind of environments. But kind of in parallel to kind of, meeting all the business demands, I know that some of my engineering team are in the audience, and I've set them a really stiff challenge over the last few years, working in conjunction with the IBM team to really start exploiting some of these technologies that you've kind of seen up here on the slideshows today. I mean, particularly in the last kind of 2 years. And what has impressed me and what has struck home with me is that, when you see a technology kind of articulated on the board like this, you always expect a level of failure in that, some of it doesn't work, some of it does work. It's quite kind of enlightening and quite a nice position to be in when I'm starting to kind of see kind of faces of the engineering team saying, this stuff actually works. And it's absolutely top stuff. So, utilisation, are we driving it up? Yeah. Are we getting return on investment? Yeah. Are we consolidating and really making a dent in our data centres? Yes, we are. So, a real positive stuff. We've taken one of those babies at the moment into our development lab now. We're just kind of cabling it up, and we're going to put it through its paces, and we expect much of the same, to be honest with you, Russell.
Great. Thanks, Craig. So, Nick, we've talked a lot about Unix. There's other operating environments that work very, very well on power systems. Can you give us a perspective from your point of view?
Yeah, sure. Parker Hannifin, actually, they're the global leader in the manufacture of motion control components, a US-based company based out of Cleveland, Ohio in the US. Their own mainframe and Power AIX out there. We don't make pens, in case somebody asked the question. International, I look after the server infrastructure for Parker out of North America. We go back to the 38 AS100 days many, many years ago. So some years ago, I had a single machine in the UK. Used to run about 500 users, mainly in Europe. Over the years, we've progressed from there through the entire range, the I-Series range to the Power Systems range. We had a couple of decent POWER4 machines. They were decent at the time, believe me. They were actually replaced in October of 2008. We put in 2 i570 POWER6 machines. At that time, we then put all our workload there, so we've gone from 500 users on a machine some years ago, expanded that over the past few years. We've now got about 10,000 concurrent JDE 5250 users on some LPARs based on those 2 machines. We've brought across about 14,000 Domino users as well onto the same machines. And in December of last year, IX on there as well. So we've now got best part of 24 LPARs split across 2 machines, highly available in every area in terms of mirroring, in terms of the software and hardware availability. So we've seen dramatic growth within Parker. We are delivering highly available systems to our end user base, and it's going better and better. I had a slight problem when I put in the POWER6 machines. The boxes were actually too quick. We had to turn off a processor because our overhand processing was basically processing too quickly, and turn the processor off to get through the night because it's going too quickly. So it's a good problem to deal with.
Great, thank you. So Terry, you've been involved in a lot of different industries and markets, but in the financial markets, the capital markets, exchanges, the rate and pace is just going at it enormously. It's accelerating. Can you just give us a little bit of experience from your point of view in that market and where things are headed?
Sure can, Ross. Yeah, it's probably the most exciting part of this industry that I've ever been involved in. We've been doing this for a lot of years. And as a result, we've seen a lot of different workloads. There are two specific workloads that IBM's always been exceptional in. One is database management transaction processing, which is mainframe heritage, right? They grew up with that. They're spectacular at that. The other end of the spectrum, and it really is the other end, is high-performance computing. Analytics, high-throughput parallelization. So at those two ends of the spectrum, you know, supercomputing, IBM's led that now for several years as a top supercomputing company. So at those two ends of the spectrum, IBM's been very, very strong. And we've dealt a lot in the database and SAP, have a lot of those installations have made a major impact in changing the way companies are doing business. But about 3 years ago, we started focusing specifically on the financial markets, mostly on capital markets, hedge funds, interdealer brokers, dark liquidity pools, exchanges. It's been fascinating to watch. Now, 3 years ago when we started, over 2/3 of the transactions were still being done by voice traders. So you pick up the phone and make an order, it gets called in, the guys run around the stock exchange floor waving their hands and making numbers and doing deals and calling them back out. They were doing that in the range of 1,000, 2,000 orders a second when they really got going. Now they're planning for, at the voice end, 5,000 orders per second. They kind of peak out at 10,000. So that's kind of their design point. Only less than a third of the transactions back then were being done electronically. Today, 3 years later, more than 2/3 of the transactions are being done by electronic traders. Less than a third in voice. If you go wander around the floor of the exchanges, there's not much going on there. A lot of guys leaning on posts. It's a whole different world. And it's been amazing to watch it happen. It's all about velocity. If I'm a trader, and what they do is they get one of these old hand traders who understands the market, they hire or they bring on as a team member a PhD mathematician, analytic person. They write the algorithms, and they bring on a couple of PhD computer scientists. They write the algorithms. This little team starts trading, and it's all about velocity. They're watching hundreds of market data feeds instantaneously. What they're looking for in arbitrage is one exchange that's selling a symbol at this price and buying at another price, and if they can see the delta and place that trade, they'll make the difference. They'll make the turn on the delta. Now, the problem is, if I buy from this exchange and I sell on this exchange, and my sell order executes before my buy, and when my sell order executes, it drops the price, and my buy order comes on later, I've lost money. I'm not trading with that exchange anymore. And they're all monitoring the return time, the turnaround time of every single exchange. Liquidity is shifting in the most amazing pace we've ever seen. It's changing the way we're doing trading. It's all about velocity. They've got to get in and get out. Now, that's created a new problem. Interestingly enough, and I've said this for years, if you owned a seat on the New York Stock Exchange and you rented it out, you could retire and have a wonderful retirement. In fact, I have a neighbor who's now 80 years old who's been living on his seat on the exchange for 40 years, and all he does is go fishing and wander around the countryside. That's all changed. Now, and I'm convinced, if you own a rack in an exchange data center and you rent that rack out, you can retire. Because we have one single problem we haven't been able to overcome, the speed of light. Hasn't changed in a lot of years. If I'm trading at the speed of light and I'm across the country, even on the other side of the city or in another country, I'm not trading as fast as a guy who gets closer and closer to exchange. In fact, if I can get inside the exchange data center in a rack right next to the exchange, that's the fastest trading I can do. That exchange pace is getting very, very expensive. Now, right now, today, in an exchange, on the average, it takes about 30 Intel servers to be able to build what we call a matching partition. You take an order in, you match it with a buy and sell, and you place the order, you send it on the market data feeds. It takes about 30 servers, give or take, to do that. But one matching engine in today's market will only get you in the range of 10, 20, 30,000 orders a second. We need 50,000. We need 100,000 at the rate things are going. The only way to do that is to, in the Intel world, add servers. If you add servers in the Intel world, what happens to the rack space in the data center? You're using it up. You're not renting it. What we want to do is reduce the number of servers. So that's what we're focused on. One of the major focuses right now is taking all of these Intel servers that are doing all these trading activities, collapsing them into virtual servers inside of a large system, and POWER7 is ideal for this, inside a large system so that all the rack space opens up. But more importantly, I want you to think about something. If I can get 256 cores, now it takes about 32 cores to do a matching partition. If I can put 256 cores inside of a single box, and of course I'm going to put a second box in because we need that kind of reliability, instantaneous reliability. So I've got two 256 core boxes inside the exchange. I'm not using all that core for trading. All of a sudden, the traders who really want to trade fast get moved inside the machine in a virtual partition. Now, we're a ways out from that, but we're working on it right now. Imagine what that's going to do to trading. And we're convinced, in the end, there are going to be two computers trading against each other in the whole world. That's all that's going to be left. It's pretty amazing stuff. But we've seen some dramatic impact of power. In fact, we've got a very large hedge fund in New York, one of the biggest around, that was trading at about 2,500 trades a second. They were actually processing their back-end reconciliation and trade breaks and stuff at about 2,500 trades a second. They knew, and this was 2 years ago, they knew that they were going to double in 3 months and double again in the next 3 months. They were running on a Sun E6900, which at the time was Spark 4 Plus, the hottest box Sun had on the market, beside, well, even hotter than their big boxes because they were slower. But the 6900 had 24 cores in it, and they called Sun and said, we need to double the cores. You can put 48 cores in this box. We need to double the cores, build this thing up. We've got to have trading space. Sun came in, put 48 cores in, all the memory they could stuff in the box. They turned it back on, went from 2,500 trades a second to 2,400 trades a second. And it cost them $3 million for that. And they said, this isn't going to work. And I went in and said, I can give you 5x that performance on 8 cores with Power 6, not Power 7, Power 6. And he said, that's not possible. And I said, give me a shot at it. Let me bring my box in. Let me load it up. I'll do it. He said, what do I have to lose? And I said, one caveat, though. If I do, will you buy it? I am a sales guy, right? He said, if you do 5x, I'll buy it. So we brought in a power box. Now, we only got to use 7 cores because we ran it in. We actually, I shouldn't tell everybody this, we actually put it in a U-Haul truck and drove it across the city. Ran it in, loaded his data center, loaded it up, put his application on it, ran it, 12,000 trades a second. 7 cores, not 8. And he went, oh my gosh. We said, there you are. And he said, that's not 5x. I said, give me a day to optimize it. And he said, I'll give you 2 days. 2 days. We optimize the operating system, optimize the database, turn it back on again, 25,000 trades a second. Now, if you do the math, that's more trades per second per core than Sun was doing in the E6900, total E6900. He bought 2. Now, a year later, and thank goodness, because within 6 months, his trading had gone up 10x. He said, what would I have done if this was on Sun boxes? But we loaded these 2 boxes up to 97%, 96%, and we said, we got to do something. So we upgraded those boxes. He's now using 2 bigger boxes. His trading's gone up another 2x since then. That's the kind of growth, the velocity we've seen in this market. It's been unbelievable. POWER7 is going to change the game. Now, if you do this in a data center, what are your choices? Well, I'll tell you what the choices are. I've been following this for 20 years. I've been saying this for 10. We're going to boil down to 3 cores. That's what's going to be left in what we'll call the commodity markets. You're going to be buying Intel from Intel, you're going to be buying Intel from AMD, or you're going to be buying Power. That's all that's left. Now, I know Larry Ellison would disagree, but he's selling Fujitsu stuff. He's not selling Sun stuff, okay? By the way, Sun told our hedge fund they could do that, so they flew him out to California. They finally got on a 128-core M9000 with 50 data feeds, and they finally matched our 25,000 trades a second at about 15 times the price and said, see, we did it. So what's left is 3, and it's not the technology. If you can't sell tens of millions of these chips a year, you can't do the R&D, you can't build the new fabrication plants. A new fabrication plant's $5 billion just for starters, and you can't keep the market going. Why is it that Power's the only RISC processor that's survived? Because they can sell tens of millions of things. They don't just put them in servers. I think I was told there were 32 Power chips in a BMW 7 Series, for instance. All the Wiis, all the game stations, all the Xboxes, that's all power. It all feeds the R&D. It all feeds the manufacturing plants. Intel and IBM are the only two that can do that. So we got 3 left. If I do it with Intel, which we're doing right now, we're building exchanges right now on Intel platforms. We're putting in 30 for a trading station, 30 for failover, 30 for disaster recovery, 30 more for test and dev for functional, 30 more for pre-production test to do one single matching partition. We're going to start putting that in smaller boxes. It's going to be a whole new world, and it's a whole bunch of fun. Yeah, these things. But I don't have one of these yet. I'm still lobbying to get one.
All right, thanks, Terry. Well, maybe I found another person as excited about POWER7 as I am. This is getting good here. Hopefully there's going to be a few of you when we're done at the same level of excitement. Okay, we have a little bit of time left. So just one quick question, a quick answer. From your company's and your industry's point of view, you've heard about all of this integrated stack capability that's being built out on POWER7. What's maybe the one biggest thing that you could imagine happening in the near future, next 5 years in your industry? I'll start with you, Kyle.
I think what we're going to see with our industry is right now we're servicing 24 million meters around the world. The growth is exponential, as I mentioned before. I think in the next 10 years we're going to see several billion. And I think we're looking forward to even POWER8 right now to be able to service those.
Great.
What we're really focusing on at the moment is not petaflop computing, because people including IBM have already done that. It's really exaflop computing, which everyone reckons that someone like IBM could build an exaflop system in about 2018, roughly. The big challenge is how we're actually going to be able to use this system, and we're really going to have to rewrite almost all the applications we run today to run on the new architecture. So we're looking to POWER7 as a step down the route towards that.
Great.
Always looking to the future, though.
Great. Thanks, Jonathan. Yeah, we haven't mentioned much about exaflop computing, but you can rest assured we're working on that. So, Craig, from a bank's point of view, global markets that are out there, where do you think that this technology could take your business?
I mean, a lot of the topics that have been discussed today kind of certainly impacts us, range from analytics through to integration, things like that. But a key thing for us is, out of adversity comes opportunity. So it's a big time to market drive for us. And that's where we're utilising virtualisation in a big way to kind of, run up the platforms and get in and exploit opportunities and generate the revenue where it's required. So I'm expecting more and more of the same, but on less and less a footprint.
Great. Great. So you got the message. Virtualization. That is the key, I think, to future systems deployment and development. All right. So Nick, what do you think from Parker Hannaford's point of view? 5 years from now, where's it all going to be?
I would say certainly more consolidation, more virtualization. I think that's where we're heading now, with the recession still kind of biting us globally. We're still finding it quite hard. Once this finally comes to an end, we can continue to expand as a business, get more into Asia, and then we can certainly consolidate what we've got already, bring it more in-house. I think POWER7 will help us both here and in the US achieve that. I truly believe that. I think there's more scope for us to bring more systems from outside of Parker locations into the head offices, both here and, say, in North America. So definitely consolidation, virtualization, and keywords all for me is availability.
Great. Thanks, Nick. Availability, rock solid availability you can count on. All right, Terry, I think you did project a bit of the future, but I mean, exchanges are exploding, all of that data and the velocity you talked about. Is there a next step? I mean, are we ready for that?
Yeah, in fact, probably I couldn't say it any better than Xavier Rollet, who is the new CEO of the London Stock Exchange. He was interviewed recently, and he said, in my vision, there will probably boil down to 5 regional exchanges worldwide. And he said, I want to be the European exchange. But if you consider that, we're taking exchanges today at 50,000 trades a second at the tops to what could be easily 1 million trades a second in those 5 major exchanges. And there's no way we're going to do that by adding Intel boxes. There's not enough room in downtown London to fill that. So I think we're going to start seeing some consolidation, but more importantly, we're going to start seeing this virtualization having a place in this high-velocity trading, because honestly, we're going to end up with very little voice, almost all electronic. It's going to be amazing to watch.
Thank you, Terry. Thank you, panel. Thank you for your time very much. Okay, Sexy black boxes are getting sexier all the time as far as I'm concerned. So one of the things that we've been doing quite successfully over the past 4 years has been running this thing we call the migration factory in IBM. And why do you need a migration factory? So one of the things we try to do is we try to convince many or maybe all of you that you should move your workloads onto IBM Power Systems. And one of the things that you tell us is that you can see the cost benefit of running on a Power System, but the risk of moving an application is something that concerns you. So this migration factory has now helped over 2,100 clients successfully move from Sun and HP, those are the majority of the systems that they were running on, onto IBM Power Systems. And we moved more than 500 clients last year alone onto IBM Power Systems. So if you're worried about risk mitigation and you want a services team that has done workload migration successfully time and time again around the world, the IBM Migration Factory is there to help you. So I'll just put that out there, that we do have services that can help you quickly and easily and take the risk out and manage the risk of moving applications and databases onto Power Systems. There's been a tremendous shift in the Unix market over the last decade. This is 10 years worth of IDC market share data on the Unix market. This chart tells a story. I call this my favorite chart. This chart tells a story of IBM realizing in the late 90s that if we didn't invest in a real different step change microprocessor and system, we were just going to completely lose out in the Unix market. And so we went to work on POWER7, the first dual-core microprocessor ever in the industry, and that was launched around the first quarter or so of 2002. And along with that micro and the virtualization technology and that roadmap that we talked about, that we said we were going to be consistent and deliver and invest and deliver that hardware roadmap for you, we've marched ourselves into 40% market share globally for Unix. Now, Power Systems run more than Unix. It is about 70% of the business, but they run the IBM I environment. And the fastest growing segment of the Power Systems business is actually Linux. Linux on Power, Linux from Red Hat and from SUSE Novell. So a lot of clients are standardizing on the Linux platform. It performs superbly on Power. And again, we've got a lot of references if you'd be interested in that. But I'm just showing you what the market share and the difference that this has made for us is back here, in the beginning of the decade, we had to pay ISVs to port to our platforms. And we don't have to do that today. We've got a lot of the ecosystem coming with us. And we have tens of thousands of applications and tens of thousands of ISVs that support us today. So we think we've got a very robust system that you can bet your business on. And again, we're not going to stand still. We know this is a race. We're not going to sit in place. We're going to continue to deliver value, price performance, and true end value to you. So what we've tried to talk about today is that Power is all about these workload optimized systems, world-class virtualization, a roadmap to continuously available applications, optimizing the energy in your data center, really reducing the complexity of managing these systems, and this integrated value all the way up to stack from IBM and from our ecosystem partners. So with that, I put up my family portrait, as I call it. These are the new POWER7 systems. Again, we'll round out the rest of the line, the low end of the line and the high end of the line later on in the year. If that's really important to you, we'll tell you about that offline if you want to hear about what's coming. I hope you've gotten something out of today. I know I've enjoyed being here. I know my fellow speakers and panelists have enjoyed being here. We appreciate having your attention, hopefully giving you some new ideas, maybe a little excitement about what possibilities lay in store for you in your enterprises. So we're about to go to lunch. Before we go to lunch, I'd like us to take one quick look at how IBM is building smarter systems for a smarter planet. Thank you very much.